So moving into our next broad topic, which is talking about prime numbers and then factorization and things coming from that. So we'll start off a prime number. What's a prime number? Well, a prime number is a number that you can only divide by 1 and itself and end up with another whole number. So we say that 1 and itself are factors of that particular number. And here are the first numbers up to 60, the first prime numbers up to 60. So for example, 11. You can divide 11 by 11 and get 1. You can divide 11 by 1 and get 11. So you say its factors are 1 and 11, but nothing else. 23, you can divide by 23 to get 1 and divide by 1 to get 23. So its factors are 1 and 23, but you can't divide anything else into 23 and get a whole number. So it's just practice for you to identify it. Why don't you fill in the remaining prime numbers up to 100? So pause the movie and work on it and come back. So hopefully you're back and you got 61, 67, 71, 73, 79, 83, 89, and 97. Now, when you don't have a prime number, so it's divisible by more than just 1 and itself, you can still use the idea of factors to break that number down, which will help you understand that number in many, many ways. So for example, we call that factorization. When we factorize 4, we say, well, 4 is equal to, can be divided by 4 to get 1, but it can also be divided by 2 to get 2. So we say that the prime factors of 4 are 2 and 2, or we can write 4 as being 2 squared. Now think about 12. I'll let you pause it and write it down and then come back. 12 we can divide by 1 and we can get 12. We can divide it by 12 and get 1. Or we can divide it by 2. If we divide it by 2, we get 6. And 6 is, of course, 2 and 3. So we can say that 12 is 2 times 2 times 3. Try it yourself, multiplying it out. 2 times 2 is 4, times 3 is 12. So we say that the prime factors of 12, or the factorization of 12, is 2 squared times 3. So fairly easy to factorize small numbers like that. And there's some ones to practice in the quizzes. How about if I gave you something like 144? Obviously, I think you could probably do it, but let's go through 2 ways in which we can factorize bigger numbers. First way is my preferred way, actually, called serial factoring. You just start dividing and keep dividing and keep dividing until you end up with 1. Now the trick is you start off as small as you can rather than trying to divide by big numbers first. So first thing to do is to try dividing by 2. Now how can you recognize if a number can be divided by 2? Well, simply, it's an even number. So you keep dividing by 2 until you have no longer even numbers or you've got down to 1. And at that point, try dividing by the next prime number up, which is 3. And it's a nice little trick to determine whether something's divisible by 3 or not. You add up all the digits in the number, and if they add up to a number divisible by 3, then it's divisible by 3. So you keep doing that until you can't do it anymore, or you've got to 1. Well, the next prime number up is 5. You can easily tell if a number is divisible by 5 because it ends in 0 or 5. So you keep doing that until no longer possible, or you get to 1, and then you keep going. If you have to, 7, then 11, then 13, and so on. So let's try 144. 144 is an even number, which means we can divide it by 2. When we do that, we get 72. That's another even number. So let's divide that by 2. And when we do it, we get 36. And that's another even number. So let's divide that by 2. And we get 18. To get another even number, divide that by 2. And we get 9. Now we can't divide 9 by 2, so let's try dividing it by 3, and I hope you would agree that we can divide 9 by 3 to get 3, and we can divide 3 by 3 to get 1. So what we've had to do to get 144 down to 1 is we've divided by 2 and 2 and 2 and 2 and then 3 and 3. So we say that the factors of 144 are 2, 2, 2, 2, 3, 3, or 2 to the 4th, 4 times 3 squared. So 4 2s and 2 3s. Let's get really adventurous and try 6300. I want you to try it first and then come back to me. So I hope you're back. So it's an even number. So divide it by 2, we get 3150. Also an even number. Divide that by 2, we get 1575. Now this is an odd number, so now let's try for dividing by 3. And we get 1 plus 5 is 6, plus 7 is 13, plus 5 is 18. So those digits add up to a number that's divisible by 3 because they add up to 18, and 18 is divisible by 3. So divide that by 3, we get 525. Let's try it again. 5 plus 2 is 7, plus 5 is 12. 12 is divisible by 3, which means 525 is divisible by 3. And we get 175. Let's add those up. 1 plus 7 plus 5 is 13. 13 is no longer divisible by 3. So now we ask ourselves, is it divisible by 5? Does it end in a 0 or 5? Yes, it ends in 5, which means it's divisible by 5. And we get 35, which also is divisible by 5 because it ends in 5 to give us 7. Now, of course, 7 is not divisible by 5, but it is divisible by 7 to give us 1. So 6,300 has 2 2s, 2 3s, 2 5s, and a 7. Or in other words, 2 squared times 3 squared times 5 squared times 7. Now, sometimes it might be easier. Can't do this for every number, but you might be able to look at a big number and say, oh, I can really quickly see that that can be broken down into 2 smaller numbers. For example, 6,300, I hope you would agree, can be broken down into 63 and 100. So I've already started factoring, but now instead of serially factoring the one number, we're going to serially factorize 2 numbers. So we'll start off with 63, okay? Well, 63 can be divided by 3, it can be divided by 3, it can be divided by 7, or you can just know your tables and know that 63 is 7 times 9. 7 is, of course, a prime number, so we're good there. 9 is not, but 9 is, of course, 3 times 3. So we can factorize the 63 part into 7 and 2 3s. Now let's look at 100. Well, 100, of course, is an even number, so it can be divided by 2 to give us 50, which can be divided by 2 to give us 25, so there's 2 2s in there, or a 4. And then we can also say, well, 100 divided by 4 is 25, and then factor both of those. 25 is 5 times 5, and 4 is 2 times 2. So adding all up again, we got the 2 2s that we said, we got the 2 3s, we got the 2 5s, and we got the 7. I sort of whiz through the factor tree a bit because it doesn't necessarily help you all the time. You have to be able to immediately or very quickly see how you can break your bigger number down into 2 easier, smaller numbers. On the other hand, if you just go serially, you will always manage to solve it.